Problem 15. For how many positive integer x, the expression x minus 1, x minus 4, and x minus 9 is negative? Okay, so this expression should be less than 0. And for positive integer, x should be greater than 0. So let's draw a number line. Okay, so we have 0, have 1, have 2, have 3, 4, 5, 6, 7, 8, 9. Okay, so let's mark this. Okay, so we mark 1 here, 4 here, 9 here. So for 1x, because x minus 1 is if equals 0, x equals to 1. So 1 could make this expression, the whole expression equal to 0. And 4 could make the whole expression equal to 0. And 9, the whole expression equal to 0. Okay, so let's test x equals 2. So then we have 2 minus 1, 2 minus 4, and 2 minus 9. Oh, let's review the rule, okay? The rule for multiplication. Okay, so negative number times negative number equals to positive. And positive number times positive number equals to positive. And the negative number times to positive number equals to negative number. The result is negative. So positive times negative number equals to negative. Okay, so then we have that. So we also can write like a negative times negative goes to positive, positive times positive is positive, negative times positive is negative, and a positive times negative, that is negative. Okay, so then from here, so we can see this is positive, negative, negative, so positive times negative, negative, negative times negative, positive, so this is greater than 0. So same as 3, so this area is actually greater than 0, okay? So then let's test x equals to 5. So then we have 5 minus 1, and 5 minus 4, and 5 minus 9. So this one is positive, positive, negative. So positive times positive times positive, then times negative is negative, oh, less than 0. So these interval, 5, 6, 7, 8. Okay, so these 4 numbers actually plug in can make the whole expression less than 0. Okay, so our answer is C. 4 positive integer x could make this expression negative. Problem 16. A gumball machine contains 9 red, 7 white, and 8 blue gumballs. The least number of gumballs a person must buy to be sure of getting 4 gumballs of same color. Okay, so we have 9 red, 7 white, and 8 blue. Okay, so what is the least number of gumballs we must buy to be sure of, okay, to getting 4 gumballs of the same color? So the keyword is be sure of. So for example, if we just buy 8 gumballs, so we can buy this way, 3 for red, 3 for white, 2 for blue. So we still cannot be sure of getting 4 gumballs of the same color. So in order to be sure of getting 4 gumballs of the same color, so let's just buy 1 less than 4, which is 3 gumballs from each color. So 3 red, 3 white, and 3 blue. So if we have bought these gumballs already, so next gumball, if we buy one more gumball, right? So no matter what color, it will make these 4 gumballs of the same color. For example, if the red, there will be 4 of red, or if the white, there will be 4 of white, or if the one more blue, there will be 4 of blue. So then the least number of the gumball we must buy is 3 plus 3 plus 3 plus 1. So that will be 10 gumballs. So we will be sure of getting 4 gumballs of the same color. So the answer is C. Problem 17. For how many 4-digit numbers like 1A, 2B are divisible by 15? So, okay, we have this 4-digit number, 1A, 2B. It needs to be divisible by 15. So we know a number is divisible by 15 if and only if it is divisible by both 3 and 5. 3 and 5. So let's say for the 1A, 2B could be divisible by 5. By 5. So only when B equals to 0 and 5. Okay, so we have 2 cases. So first, B equal to 0. So 1A to 0 can be divisible by 5 already. So we just need to make sure this number is divisible by 3. So we add the divisibility test for 3 is the sum of all the digits is divisible by 3. Then the number is divisible by 3. So then we add all the digits. So equals to 3 plus A. So this sum needs to be divisible by 3. So then 1A to 0 could be divisible by 3. So the A, if equal to 0, to 3, to 6, to 9, so that sum could be divisible by 3. So the number 1020, 1320, 1620, 1920. These 4 numbers could be divisible by 3 and 5. So then divisible by 15. Okay, so second case, B equals to 5. So then we have a number is 1A to 5. So we add all the digits. 1 plus A plus 2 plus 5. So it's 8 plus A. So this sum needs to be divisible by 3. So then the original number could be divisible by 3. So the A, which is 1, 4, 7. So the number like 1125, 1425, 1725. So these 3 numbers can be divisible by 3 and also 5. So that it could be divisible by 15. So total, how many numbers? 4 here, 3 here. So total is 7. So which is D? The answer is D. Problem 18. Emily took selfies with her 8 cousins. Each of the 8 cousins is in 2 or 3 pictures. In each picture, there are exactly 5 cousins. How many selfies did Emily take? Okay, so we have 8 cousins. So how many times the total times of 8 cousins in selfies should be great equal to 8 times 2, 16, and less than 8 times 3, 24. So we have this number, which is between 16 and 24. And this number has to be divisible by 5, because in each picture there are exactly 5 cousins. So then, okay, let's think about this. It should be 20, right? So each picture has 5 cousins. So 20 times and 4 selfies. So answer is B. Problem 19. How many pairs of positive integers x, y satisfying that 3x plus 4y equals 120? Okay, so method 1. We have equation 3x plus 4y equals 120. So x should be greater than 0 and the integer, positive integers. So y greater than 0 and the integer. Okay, so then we have, so 4y has to be less than 120. So y less than 30. So let's just try the number, 30 numbers from 1 to 3 until 30, and the extra 29. We cannot use 30. Okay, so we found out actually when y equals 3, 6, 9, 12, 15, 18, 21, 24, 27. So then we have x. We can solve for x, and it's an integer. And the other numbers doesn't work. Okay, so we have method 2, because we have to try 30 numbers. It's still too many cases. Let's narrow down the y values. Okay, so because we have 3x plus 4y equals 120, so 3x is a multiple of 3. And 120 is a multiple of 3. So 4y also should be multiple of 3. So let's review this property. So for example, we have equation a plus b equals c. So if we have 2 numbers in this equation, okay, a is multiple of some number. Let's say 3 in this case. And c is also multiple of 3. So then b has to be multiple of 3. So for example, we have 3 plus 12 equals 15. So multiple of 3, 12 is a multiple of 3. So if we have 3 plus 8 equals 11, this is a multiple of 3. This is not, so 11 is not. Okay, so then we know 4y has to be multiple of 3, and the y should be less than 30, and multiple of 3. So then we have y equals 3, 6, you know that list, okay? 9, 12, 15, 18, 21, 24, 27. So then we plug in to see if we can get the solve for x as integer greater than 0. And x greater than 0. So we test each one, it works. So then total number, actual total pairs is 9 pairs. Okay, so 9 pairs, which the answer is A. Problem 20, the integers 1, 2, 3 to 20 are written on the board. What is smallest number of these integers that can be wiped off so that the product of the remaining integers ends in 2? Okay, so we have 20 integers, 1 to 20. So if we multiply by them, all of them, so obviously the unit digits would be 0, right? So then we can wipe off some integer. So for the remaining, the product of the remaining integer ends in 2. So of course we need to wipe off first, we need to wipe off 10 and 20, okay? So what else? So let's look at the 5. So if we have the factor 5, so 5 times 2, so then will result in 0. So unit digits would be 0. So we need to wipe off 5 and a multiple of 5, 15. So okay, so far we have wiped off 4 numbers. So let's look at the remaining integer. What are the unit digits of the product of these remaining integers? So remember, when we plus minus multiply by positive integers, the unit digits of the results is determined only by the unit digits of all the integers involved. So then we just need to check the unit digits, okay? So we can do this quickly. So 1, 2, 2, which is give us unit digits 2, 2, 2, 6, 6, 6, 2 times 4 is 24. Then we use the unit digits 4 times 6. So would it be the 24 again? So then unit digits is 4. Then 4 times 7 is 28. So use the unit digits 8 times 8, 64. Then use 4 times 9, 39. So this unit digits, actually these one, the unit digits is 6. Okay. So it would be same for these numbers because we just need to use unit digits to multiply each other. So it would determine the unit digits of the product. So then we have 6. So these would give us 6. So we have 6 times 6 unit digits. So it also will be 6. So that means the remaining product, product of the remaining integers would have the unit digits is 6. So it's not unit digits. It's not 2. So we need to wipe off 1 more numbers to give us the ending in 2. So how about let's wipe off 3. So see, because we wipe off this 3, so this unit digits would be 2. So 2 times these still 6. So the unit digits would be 2. So that's the 5 number we wiped off. 3, 5, 10, 15, 20. So the answer is A, 5. Okay, total 5 number we need to wipe off.